So you've got a question, you've got a hunch, and you're pretty sure the answer is hiding somewhere in the data. But how do you actually get from that nagging question to a solid, trustworthy answer? Well, today, we're going to walk through that exact journey and demystify the art of data analysis.
Let's start with something we've all probably thought about. You know that feeling? It just feels like it's been raining more this year, and you're seeing less of the sun. But is that real, or is it just a feeling? How would you actually prove it? A simple, everyday question like this is the perfect starting point.
So let's do it. We're going to follow the exact path a data analyst would take to crack this exact problem. We're going to see how they transform a bunch of raw numbers into real, actual insight step by step.
Okay, before we start our journey, we need to talk about the toolkit. You can think of a data analyst as having three fundamental powers at their disposal. And if you understand these three, you'll understand the whole process.
First up is descriptive analysis. This is basically the power to see the past with perfect clarity. It takes a giant, messy spreadsheet of raw data and boils it down into something simple and understandable, like a chart. It doesn't tell you why something happened, it just shows you exactly what happened.
Next, we have inferential analysis. This one is super clever. Look, it's almost always impossible to survey an entire population, right? So instead, analysts take a small, random sample and use that to infer what the whole group is like. Think of it like trying to sketch a whole park just from one really well-chosen photograph. And finally, my personal favorite, predictive analysis. This is the power to see the future. This is where we use past data to find those hidden relationships and make predictions. For example, we can build a model that predicts a car's braking distance based on its speed. And guess what? This is the power we're going to use to answer our weather question.
So, we've got our toolkit, we know our three powers. Now, let's actually walk the path. Let's go on the step-by-step journey our analyst takes to get from that first little question to a rock-solid conclusion.
Now, in the real world, this can get pretty complex, but it almost always boils down to these four key phases. You have to start by knowing exactly what you're trying to prove. Then you gather your raw materials, the data, and clean them up. Then comes the fun part, the analysis. And finally, you have to share what you found.
Let's dive a little deeper into that second step, collecting and cleaning the data. Because, and this is so important, it's just like cooking. If your ingredients are bad, your final dish is going to be bad. No way around it. The quality of your raw materials is everything.
Data basically comes in two main flavors. First, you've got primary data. This is the stuff you go out and collect yourself for this specific project. You know its whole life story. Then there's secondary data, which is stuff someone else collected that you're just reusing. It's incredibly useful, but you've got to put on your detective hat and really investigate its quality.
And when we can't study everybody, we take a sample. The easiest way is simple random sampling. Everyone has an equal shot of being picked. But sometimes that can accidentally miss key groups. That's why we have stratified sampling. You split the population into groups, or strata, first, then sample from each. This makes sure your sample actually reflects the real world. And of course, today we have to talk about big data. It's not just the data sets are huge now. It's the sheer speed and variety of the information coming at us. It's so messy and moves so fast that the traditional ways of doing things just can't keep up. It's a whole new ballgame. All right, deep breath. We've defined our objective. We've gathered our historical weather data. Now, it's the moment of truth. It's time to unleash that third power, predictive analysis, and finally get our answer. So picture our analyst. They've cleaned up all that weather data, and now they are feeding it into a statistical model. The entire job of this model is to find the exact mathematical relationship between how much it rains and how many hours of sun we get. So this is what it all comes down to, this one specific question. The model has crunched the numbers, so what's the impact? For each extra millimeter of rain we get, how much daily sunshine do we lose? 6 minutes. That's the answer. For every additional millimeter of rainfall, the model predicts we lose, on average, 6 minutes of sunshine per day. And just like that, we've gone from a vague feeling to a precise, data-driven number. How cool is that? We have our answer. Amazing! But hang on a second. In a world where people are constantly throwing stats around, getting an answer is the easy part. The hard part is knowing if you can actually trust it. How do we know this isn't just a fluke or a mistake? And that question leads us to what might be the single most important concept in all of modern data analysis. It's a golden rule, and it's called reproducible research. The idea is actually pretty simple.
It just means that when I report my results, I also have to provide all my data and my code, my exact recipe, so that any other person can come along, repeat my analysis, and get the exact same results. It's the ultimate show your work.
And this is a huge change from the old way of doing things. You know, manually clicking around in a spreadsheet, making notes that are easy to forget or mess up. The new way uses automated code, which creates a perfect, transparent audit trail that anyone can follow from start to finish.
So why does this matter so much? Well, for one, it builds trust. It allows anyone to check your work. It also makes it incredibly easy to update the analysis when new data comes in. And honestly, the discipline it requires just leads to fewer errors and better work, which gives everyone confidence that your conclusions are justified.
Now, here's a really critical point. Reproducibility doesn't guarantee that an analysis is correct. You could have a perfect reproducible recipe for a really bad cake, right? But what it does guarantee is that your work is transparent. Your recipe is out in the open where it can be challenged, debated, and ultimately improved. It's about transparency, not perfection. So from a simple question about weather patterns to a massive business decision, this is the journey. It's a structured, repeatable, and most importantly, verifiable process that turns the chaos of raw data into insights we can actually trust and act on.
And that just leaves us with one final thought. We started this whole thing with a simple question about rain and sun. But this process, it can be applied to almost anything. So what's a simple question in your world that might just be waiting for the right data to come along and answer it?